This lesson is on how to use Hooke's law with dynamics problems involving strings or springs, and it's the closest thing that M3 gets to a nice easy topic. It's based around the idea that you have the sum of the forces is mass times acceleration, so it's Newton's second law, and the force may be from an elastic string or spring. Okay, so here I've got an object attached to something under tension, and if this is an elastic spring, then if the tension is great enough, then the mass will accelerate upwards. In this first exercise, it's pretty straightforward, so I'll just go through it quite quickly. We've got a 4 kilogram mass here attached to a elastic spring, and the spring's natural length is 0.5 meters. So in this case, the spring is stretched to 0.8 meters. It's fixed at one end, and obviously the other end is attached to the mass. So set in the sum of the forces, which is basically just tension. So the sum of the forces is mass times acceleration. So tension here is equal to the mass 4 times by the acceleration. So tension from the previous little exercise, or the previous section of the course, was lambda x over L. So putting in the values, my lambda is given to me as 40. The extension is 0.3 because the natural length is 0.5 and the current length is 0.8. So we've got a change in length of 0.3. The original length is 0.5 as previously mentioned. 40 times 0.3 is 12. Divided by 0.5 gives us 24 newtons. So 24 newtons is equal to 4A. So A must be equal to 6. Then in the second part of the question, there is a compression. The spring is compressed to 0.4 meters. So exactly the same situation. Sum of the forces is mass times acceleration. Tension is equal to 4A. The tension this time is different because we've got a compression of 0.1 meters. The original length is still 0.5 and lambda is still 40. So 40 times by 0.1 is 4, divided by 0.5 is 8, which is equal to 4A. So 8 divided by 4 gives us 2 meters per second for the acceleration. And I will now do a slightly harder example, but that's basically the basis behind all of it. Good luck.